Yeah, hi. So today I'm going to explain about the construct of all the binary tree. So in our traversals, so it means that you will get one kind of number, which indicate the how many number of node is possible. Okay, and based on that you have to construct all the kind of possible binary tree, basically all the possible binary tree. So let me explain. Suppose that number of node which is given the 1, then it means that we will have the only one possible node just for the indicating of the number, that I'm indicating 1. This is the condition when total number of tree it will be only 1 if their n value equal to 1. If n equal to 2, then it means that we can draw the binary tree like this, and similarly one node it will be like this, and they're attached with the right node. Okay, so this is the two node here, just 1 and 2 just for the indicating of the node, just I am taking, but order can be anything, right? So it means that one node might have, one tree might have the left child and other tree might have the right child. This is the two possible value when the value of the n equal to 2. Suppose that 3, it means that this is the possible node, left. Similarly, it might be the possible. There might be the node 1. Similarly, there might be the possible one node will be this, and this is the third, left and right. Okay, just for the indicating that. Then after that, it can be possible 2, and then after that it will have the right child, and it might be that like this. Okay, so this is the possible tree. This is the possibility 1 2 3 4 5. So similarly, so it means that if you have the 3 nodes, so based on these 3 nodes we can make the this possible tree. So here the number of tree will be the 5. So if you will see, this is the kind of recursive solution, right? Recursive solution, it means that we have to create the array list of the, which contain the list of the tree, and we have to identify that what is the left side tree and what is the right side tree. Okay, and recursively whatever the number is there, like if you I explained that if there will be the 1, it will be there is a left side and right side both will be the null. In that case only one possible combination. Okay, similarly if so thing is that we have to identify what is the possible different tree on the left side, what is the possible right side, and then after that we can make the merge to the root. Okay, and this is the recursive solutions which we can do. So what I am saying, I just let me show the code. So what I said, recursive solution, it means that, see, here I always creating the node based on the start and end node. A start might be the 1 just for the indicative purpose, and it will be the end. Okay, so here if you will see, I creating the temporary list. This is the temporary list, and where for every node starting from the start positions to the end, just I constructing the possible tree. How many trees possible on the left side? How many trees possible on the right side? Okay, so this is the means recursively which I am trying to get the tree right here. And here the breaking condition is that moment when I start is greater than end, it means that either the end equal to or less than. So in that case, this recursive function it will break. So this is the base condition, and it will return a singleton list. So in this case, recursively just I try to get it. What is the left side tree? What is the list of right side tree? Once I got will get, then nothing but here creating the node recursively, and this is the possible node. Whatever the possible node is there for the specific that a starting node or end node, basically, if you will see here. Okay, for the specific root nodes, just creating the nodes and adding into this temporary array, and finally this temporary array is nothing but it is returning back to the upper means as you know that this all recursion is work into the tree, right? Work into the stacks, all the function call basically. So function call it is happening into the as per the stacks. So it's all tree it will be uh, passed from the this upper means lower level call to the top level call. Okay, like this. Okay, like this. So it means that it will be returns all the list, and then after that it will create the based on the root node, right? So whatever it is going to return finally. In that case, means finally it means that whatever you will get return here, basically, then in that case all the node from 1 to n, all the node it will be purchased. Okay, all the node it will be purchased, and you see you will get all the possible list also. So let me see what is the value of the two, how many size. If you will see here, it means that it is returning the 2. Okay, 2 it means that just every tree I iterating into the in order. And similarly if you will see there the 5, there is 3, so it means that it will add the 5 times. Okay, if you will see here. So it means that 1 2 3 4 and 5. Okay, so we are getting the expected results. We are here creating the all the possible binary tree of n number of nodes here, and I also got it. Means how the recursion here the main understanding to solve this problem, that we have to understand how the recursion is work basically, and how we'll take the advantage of the recursion to solve these problems. So here nothing but recursively I calling the left tree and right tree. Just it means that I am making this left tree and right tree, and then after that creating the nodes. And this all tree whatever this value is there is nothing but you can consider like a temporary array in terms of here in the final return whatever is there between 2 and 2 n, because our start or end always it will be the same in this loop. Okay, and whatever the finally it will return, it will contain the all the nodes from 1 to n, and it will give the all the possible trees. So recursively nothing but I break out down this whole recursion into the subset. Like example as I got three nodes. So first I solving that. How many node is possible with the 0 nodes? How many node tree is possible with one node? And then this again I adding to the with the 2, and then after that 3 basically. So that is the meaning of recursion. First this all tree it will be give return back for this with the 0 nodes, then after that with the 1 node, then 2 nodes, then 3 nodes, so and so up to n node. So I hope so you got it, how the this tree, which is the kind of, if you will perform the iteration operation, then it kind of the temporary tree, because uh, because every recursion is called into the stack basically, and every function call will have their own list. Okay, and this list is nothing but it is returning to the caller application, which might be the left tree, it might be the right tree based on the conditions. Okay, so moment when it will be reached again here, then it contains the all the node between 1 to n. Okay, based on this condition basically, because the start from root -1 and root +1 to int. Okay. So I hope so you got it. Thank you.